Okay, this is Project 3 demo. Right now, it is currently, we need DC voltage on two different ones. So we're just going to start with 500 millivolts. And we're seeing 500 millivolts there, and on the bar graph as well. And we'll switch this guy up to 2 volts. Go to 2.5, which is the limit, and we're seeing 2.5 there, and as well on the bar graph. And now we'll be doing the AC for sine at 500 hertz. And 1.5 offset. That's what we're getting there. And for here, that's our sine wave. It's our true RMS and calculated RMS, as well as our peak-to-peak voltage, and the frequency, which is roughly 500. Now 1 volt peak-to-peak.
Definitely going to adjust that.
With a frequency of 1,000 hertz.
I want to increase my Q.
And an offset of 0.5.
Right now I have a Q of 1/2. If you use the same R and the same C for both, it forces you to have a Q of 1/2, which isn't ideal. Getting it to like 0.8, I think is better. And maintaining. I'm actually using standard resistor parts. Like changing.
And our sine frequency is a bit off, 300 hertz off. Sine, we're getting the RMS values, and peak to peak, we're seeing 1 volt, which is good. And now we'll raise the offset to 2.5. At 1,000 hertz. And this is where our frequency kind of breaks down. We're not reaching the full 1,000 hertz, but peak to peak is fine and RMS values are okay. Now we'll need a 3 peak to peak triangle wave. With the offset of 1.5 volts at 50 hertz. Hertz, 3 peak to peak, 1.5 offset, and we're reading that triangle, and frequency is accurate within 5 hertz. Square. 10 hertz now. Amplitude of 1 volt, and offset 1.5 as well. So frequency is 10, that's perfectly accurate, and our correct values for RMS and peak to peak. Now to control the frequency, we'll change it to, we'll keep it on the square wave with 1.5 offset at our lowest hertz. 3 volts peak to peak. I think our lowest is 10. No, bring it to 100. And so frequency we get 1. And voltage is a bit off since you can't get just like samples in there. And then the sine wave. Now it's at 1,000 hertz. Not 2,000. And our frequency is accurate within 50 hertz.